Have Mr. Hassanuzzaman Ashik from Fiber at Home. He is a network automation engineer with extensive knowledge on routing, telemetry, Python, and databases. He is going to talk about an overview of network monitoring technologies and introduce the Telegraph, InfluxDB, and Grafana stack. I'd like to request Mr. Ashik to take the stage. ফ্রি মাইক লাগবে নাকি এটা দিয়ে কথা বলতে হবে আপনার প্রেজেন্টার দেওয়া আছে এখানে এটা হচ্ছে মাইকটা এই পর্যন্ত আসলেই কথা ক্লিয়ার হবে না
Good noon, everyone. I am Jaman from Fiber at Home, and it's a pleasure to get the opportunity. It's a pleasure for me to get the opportunity to able to talk about visualizing telemetry in TIG stack. So let's get started with our agenda. Many of us are familiar with some sort of NMS for managing and monitoring our devices, but have you considered the effectiveness of your monitoring system? How much accurately can you collect data from your NMS? Can you query from your NMS databases? Or can you build your own applications taking data from your NMS? Do you need to rely on vendor-specific NMS that cannot talk with each other? What if I told you that you can build your own NMS that can do all of these things and much more using TIG stack and telemetry? So today we will discuss about the evolution of monitoring technologies and what TIG stack is. We'll get to know some terminologies of telemetry and drawbacks of protocols like SNMP and why we need telemetry. And then we will see some real-life implementations of telemetry in Grafana. And finally, we will discuss some key concepts that need to consider before deploying at large scale. If we look back, in the 1990s and 2000s, SNMP became the go-to protocol for monitoring our networking devices. But as it is a pool-based systems, it creates some overhead in the server. So we need to look for some newer protocols. In the 1990s and 2000s period, protocols like Ramon, NetFlow, and APM has been introduced. In the 2010s, flow-based monitoring systems became much more popular. Here, telemetry has been emerged as a new technology in network monitoring, offering real-time visibility and more efficient troubleshooting. In 2020s, cloud-based monitoring technologies became increasingly important, offering scalability and ease of deployment. As we have seen 5G network technologies and software-defined network technologies monitoring became much more important. TIG stack is well positioned to keep pace with these advances. So what TIG stack is? TIG stack stands for Telegraph, InfluxDB, and Grafana. If you show in the diagram that there is a pipeline called Telegraph that collects data from our networking devices. InfluxDB is a time series database that stores the data, and from there we can build our dashboards using Grafana, and using Python applications or any other programming languages, we can build our own applications to serve our purpose. So telemetry is a remote data collection technology that provides real-time and efficient data collection from our devices. It is high speed and we can get live data from devices. It uses young models to organize our data, and gRPC allows us to serialize those data more effectively, and we can encode data using Gokul protocol buffer format. If we see some drawbacks of SNMP, as it is a pool-based system, it creates, as I said earlier, that overhead to the server, and The MIP structure is MIP or management information base of SNMP is unstructured sometimes, and the device need to process each and every request that is sent from the server. So large scale deployment is much more problematic here. Now, to address these limitations, telemetry can be deployed in push model. It uses gRPC to connect with the server, and using long live TCP connection, we can send the data to the server. All monitoring information gets streamed to the server. It supports advanced application specific monitoring and easily scalable as device initiates the TCP initial connection. And young models, unlike MIP structure, it is much more structured, and it improves our data collection efficiency. Now, telemetry has two types of deployment. One is model-driven telemetry, and another is policy-based telemetry. We will discuss model-driven telemetry in this presentation only. If we see in the diagram, the data flow comes from the device to the server. Here we have to initiate a subscription using a sensor path and a destination path. Here destination is server address, and sensor path is the path that the parameter we want to monitor from our device. So after creating the subscription using a interval or any time in cadence value, then the device streams data to the telegraph pipeline. Here in the telegraph pipeline, the data get decoded, and then it processes the data and stores it to time series database. In the encoding option, it supports GPB compact or key value GPB or JSON. Now JSON is human readable, but it consumes much more bandwidth, so it creates some overhead. In compact GPB, it is much more wire efficient. Now, there are two terminologies in telemetry. One is TCP dial out and dial in method. In dial out, the device initiates the initial TCP connection. In dial in, the server initiates the connection. So it is like one is in dial out, it is a push model, and dial in is a pull model you can consider. Here dial out method is much more efficient. In the dial out, we can also establish connection using TCP, gRPC, or EDP method. Now, telemetry pipeline, it is written in Go language, and it is plugin driven. There are lots of open source plugins available, and so that it is very powerful for collecting our data from various sources. Here you can see it has 251 types of input plugins. There are 57 types of output plugins, and lots of plugins available. Here systems plugins available, networking plugins, and cloud plugins available. So it can be deployed in infrastructure so that it can monitor every type of devices of our network. This is the basic configuration of telegraph. It has three portions. One is global telegraph agent portion, and we can specify output plugin configurations and input plugin configurations. If we take a look here, our agent is configured at 300-second interval or 5-minute interval, and we have specified some other parameters like log file locations where we want to store the log files from telegraph, and the return how much files we want to store there. In the output plugin sections, we have specified the credentials of our InfluxDB database. Here is the standard configuration of Cisco telemetry for XR devices. The port is specified 57,000, and the protocol is transport layer protocol is specified gRPC. Now, after getting data, the device needs to configure with telemetry so that it sends the data from the device as device initiates the connection. So if we take a look here, we have a destination group and optics group, and sensor path groups. One is for optical power information monitoring, and another is for interface bandwidth utilization monitoring. After specifying those groups, we make a subscription at different interval. One is 15 minutes and another is 5 minutes. It can be configurable at millisecond intervals, so we can get data from the device at that interval. After configuring this, we can see that the sensor paths are resolved, and we can see the state is active, and so the device is now has successfully established the connection with the server, and started streaming the data to telegraph. So what data is getting sent from device to telegraph, we can see by running this command, run mdt exact -s the sensor path. And from here we can see that lots of information are coming, like packet how many packets got received, the CRC errors, and much more. And this is specific to this particular sensor path generic counter. There are lots of sensor path available, and this is available in official documentations of vendor specific device. Now, InfluxDB is a time series database. It is different from our traditional well-known RDBMS database. The terminologies are different here. The database are called buckets, the tables are called measurements, and the columns are called tags and fields. You need to specify which one you want to use as tag values and which one you need to use as field values, so to optimize the cardinality of the entire database. Now, InfluxDB supports two types of query language. One is InfluxQL and another is Flux. Flux is a scripting language, and it is different from query language. It is very powerful from collecting data from the time series database. And InfluxDB accepts data in a special protocol named InfluxDB line protocol. Here the format is starts with the measurement name separated by 1 comma, and then tag names separated by space, and then field names separated by comma, and finally the timestamp of that particular time. Here we can see in the example that our telegraph measurement has a tag named location, which is Dhaka, and we are specifying temperature and humidity values as field values, and then finally a timestamp. Now, InfluxDB version 2 has a graphical user interface from where we can maintain the database parameters like the retention policies of our buckets and measurements, how we can delete our buckets and measurements from this dashboard. We can build our Flux queries and Influx queries from a dashboard like this. So we need not know the SQL language or Flux language in details. From a dashboard, we can build our own query languages. We can also see which data are getting stored in the same dashboard. Let's see some deployment of telemetry in some dashboards. Here we can see Cisco XR router, CPU utilization, uptime, interface summary, and optic link utilizations are visible here. In the another implementation, here you can see that optical power information is also visible. So this is built using Flux query language, and the previous one was built using InfluxQL language. Let's take a look at the Flux query. Here we are querying data from telegraph named bucket, and we are filtering those data at specific time interval, and then filtering out by a sensor path, and then field, source, and interface names, and aggregating the data at 5-second interval. Then we have calculated the counter value differences to get the actual value of interface, and then converted them to Mbps unit by using map function. Let's see, so why we need telemetry. Our NMS is already using SNMP. So by using telemetry, we can monitor our devices at millisecond interval, or we will get high resolution data from our devices. So we can detect microburst traffics. We can build our own dashboards for generating some alarms. We can also integrate SNMP devices. We can integrate devices that do not support telemetry. So in a single dashboard, everything can be monitored. Here we can see that the actual difference between 5-second and 5-minute real-time values. Here we can see lots of traffics are coming, and lots of spikes are getting detected at 5-second interval. We can see the maximum utilization is at 100 Mbps, but at 5 minutes we can see no significant spikes there. So if we continue to monitor at 5-minute interval, we do not know that our actual application was sending traffic at much more bandwidth. So we cannot actually know that there is an issue is ongoing in our network. So by visualizing those microburst traffics, we can plan our capacity of the entire network so that client get better service from in the infrastructure. Here is another dashboard that was built using Python Django application for monitoring optical power informations from for our Cisco XR devices. Here we can build our own applications to generate alarms. Here you can see that we can see alarms getting generated at a custom value. For example, where we are defining threshold as 19, when the receive power gets over this custom value, an alert gets generated and get visualized in this dashboard. So this is just an example. We can build any applications by taking data from the database, as we can write query to the database. We can also get alarms at our most popular apps like Telegram or Slack from Grafana, and we can, so that our team can take actions immediately. Grafana can be also integrated with other tools like Syslog, and we can combine dashboards by preparing complex database queries in a dashboard. Here is an example of a dashboard by taking data from Syslog database. We can see the OSPF fluctuation of today and yesterday reports, and see how many links got solved and how many are still existing in our network. We can deploy our legacy devices by using SNMP in the same InfluxDB infrastructure or TIG stack. Here Cisco 901 model device utilization is utilized in the in this model using SNMP. Here we can see the our gig port 11 interface utilization. We can also bring optical power using SNMP in the same infrastructure. Now, before going to deploy at large scale, we need to consider which version we want to use, because InfluxDB version 1 and version 2 are different. Version 2 has a dashboard from where we can manage our databases, but version 1 is more preferable for enterprise-based solutions. We need to consider the series cardinality of our database, which one we want to use at tag values and which one we want to use at field values. We need to also consider the CPU and RAM of our server so that the InfluxDB performance gets at stable. So these are some references from where much more information can be found. And if you have any questions, please.